All right, let's dive into one of the biggest technological shifts of our time, the move to the cloud. We're going to talk about how we went from closets full of blinking server racks to a massive global network that powers pretty much everything we do online. Let's get into it.
Really think about that for a second. You've got this massive, sudden surge of millions of people all hitting the same app at the exact same time. In the old days, that would have been a total catastrophe. But today, for the most part, things just work. Well, the secret behind that magic is exactly what we're going to unpack. And it all starts with a look back at how things used to be done.
So before the cloud came along, the world of information technology was a very physical, very hands-on place. If you wanted to run a website or some application, you had to build, own, and manage everything yourself.
Just look at how tangible all this is. You had physical servers, these big, heavy metal boxes, humming away in your own data center or a closet somewhere. You had to buy the networking gear, you had to physically plug in all the cables, and if you wanted backups, you needed even more physical servers. You owned it, you could touch it, and you were on the hook for it 24/7.
And, this whole approach came with some major headaches. What if your website suddenly got popular overnight? You couldn't just snap your fingers and get more power. Nope. Scaling meant ordering new hardware, waiting for it to arrive, and then physically installing it, a process that could take weeks or even months. And when a server broke, someone had to physically go fix it. The whole model was just incredibly expensive, slow, and made it almost impossible to adapt quickly.
So, the first big step away from this rigid physical world was a truly revolutionary idea. Someone asked, what if we could break the link between the physical machine and the software running on it? And that idea was called virtualization.
At its core, virtualization is really all about efficiency. Instead of having one operating system totally tied to one physical server, this technology lets you run multiple, completely isolated virtual computers on a single piece of hardware. Think of it like turning one giant, powerful computer into lots of smaller, independent ones, all sharing the same physical resources.
So what's the magic that makes this possible? Well, it's a piece of software called a hypervisor, and it comes in two main flavors. You've got Type 1, or bare metal, which runs right on the server's hardware. That's what you use for maximum performance. It's basically the engine of the modern data center. Then there's Type 2, which runs on top of an operating system you already have, kind of like software that lets you run Windows on your Mac. But either way, they both follow that same core idea. One machine, many worlds.
Now, virtualization was the key. It was the enabling technology. But the real revolution, the absolute game changer, came when companies like Amazon Web Services or AWS took this concept and applied it at a mind-boggling planetary scale. This right here is the birth of modern cloud computing.
There are two phrases here that are absolutely crucial: on demand and pay for use. This completely changed the game. It meant you no longer had to buy servers up front. You could just rent them instantly over the internet, and you'd only pay for what you actually used, down to the second. It's just like your electricity bill.
And this is the payoff. You can see the direct line from the old problems to the new solutions. All those headaches we talked about, the cloud has an answer. Scaling, which was so hard before, becomes almost automatic. Those huge upfront hardware costs, gone, replaced by a simple pay-as-you-go model. And that lack of agility? Now you can spin up new resources in minutes, not months.
But here's the thing. The cloud isn't some mystical entity just floating up there in the sky. It's real. It's a massive, physical network of interconnected data centers all over the world. So let's take a look at how a provider like AWS actually builds this global computer.
The entire AWS world is organized into what they call regions. A region is just a specific geographic area, like US East over in Virginia, or EU West in Ireland. When you deploy an application, you choose which region it's going to live in, and you usually pick the one that's closest to your customers to make sure everything runs as fast as possible.
But a region isn't just one single building. No way. It's made up of multiple, isolated locations called availability zones, or AZs for short. Now, each AZ is its own fully independent data center, with its own power, its own cooling, its own networking. They're built far enough apart so that a local disaster, like a flood or a power outage, won't affect the others, but they're close enough to be connected by these ultra-fast private networks. This structure is the absolute key to building apps that can survive almost anything.
So now we have this amazing global network of virtual machines ready to go. Let's connect this all the way back to our Super Bowl problem. how does this incredible infrastructure handle those massive, totally unpredictable spikes in traffic? Well, the answer is a beautiful concept called elasticity.
The main way the cloud gives you elasticity is through something called horizontal scalability. Instead of making one server bigger and more powerful, that's called vertical scaling, you just add more identical servers to share the workload. It's literally like a supermarket opening up more checkout lanes when the lines get really long. Simple, but brilliant.
And the best part, the absolute best part, is that this can be completely automated. Use a tool called an auto-scaling group. You just tell it, hey, I always want at least this many servers running for your normal traffic, and don't go over this maximum number for peak traffic. The system then just watches your application, and if things get busy, it automatically adds new servers for you.
So here's how it works in real time. Your app goes viral, or the big game kicks off. Demand spikes. The auto-scaling group sees this, and bam, it automatically scales out, launching new servers. Then, when the traffic dies down, it scales in, terminating those extra servers so you immediately stop paying for them. That is the magic that keeps your apps running smoothly while saving you a ton of money. Okay, so this incredible power and flexibility is completely transformative. But, it also changes how we have to think about security. When you're renting all this infrastructure instead of owning it lock, stock, and barrel, who's actually responsible for keeping everything safe?
Well, AWS answers this with something they call the shared responsibility model. And it's a really important concept to grasp. It's not all on them, and it's not all on you. Security in the cloud is a partnership, with really clear lines that divide up who does what.
To put it really simply, AWS is responsible for the security of the cloud. That means the physical data centers, the guards, the fences, the hardware, the global network, all that stuff. You, as the customer, are responsible for security in the cloud. That means it's your job to protect your data, secure your applications, and carefully manage who has access to your resources.
I think this analogy just hits the nail on the head. It's the perfect summary. Very few businesses today would even think about building their own power plant, right? They just plug into the grid. The cloud has done the exact same thing for computing power. It's removed this massive barrier and has democratized access to world-class infrastructure for everyone. This fundamental shift has just unlocked an incredible wave of innovation, everything from the streaming services we watch to groundbreaking AI research. And it leaves us with one really exciting question to think about. Now that we have access to nearly limitless and affordable computing power, what incredible new things are we going to build next?